Hello, everyone, and welcome back to the second episode in this series, which is a tutorial on how to code in Java. So, essentially, in the second episode, we're going to be talking about variables and a little bit of mathematical operations and a bit of variable manipulation. So, if you recall, in the first episode, we just went over the main method and what a class is in Java. So let me just briefly recap. Everything you do for now should be inside of this main method. Every Java program should have a main method, and a class is where you write your code in Java. File name and the class name must match, and you kind of run this class in this terminal window over here. So I'm going to go ahead and clear. So without further ado, let's get started. So before we jump into what exactly the different types of data types there are and so forth, we should first define what a variable is. So if you've ever been in math class and if you've seen an equation like 4x plus 1 equals, I don't know, let's say 9, you would know that x is a variable you have to solve. And x holds a number, which is the answer to your equation. Basically, a variable is something in which you can store a value in. So for example, I can declare a variable called x, and I can set it to store my name, or I can set it to store my age, things like that. Now, in Java, when we want to declare when we want to have a variable and store it, we can have a variable store different types of data. For example, we can store arrays in a variable, we can store text, we can store numbers, we can store fractions, and more. But we'll just be going over the very basics that you need to know of how to store text and numbers and true or false statements in this episode today. So, when declaring a variable in Java, it's important that you state its type before the variable name and you assign the variable to a value. So let me give you an example. The first variable that we're going to go over is one that can store numbers. So there are a lot of the different types of variables that can store numbers, but the one that we're going to go over is int. Now, int is a primitive data type, and Java has 8 of these primitive data types. What exactly are primitive data types? The primitive data type specifies the size and type of the variable values, and it has no methods you can invoke. And I'll explain this a bit later when we cover strings. So, but for now, let's go ahead and create a variable that stores the number 35. So all we say is int, and we say variable name, and feel free to replace the variable name with whatever you want to call the variable, is equal to 5, like so. And you'll get some error. It's not used. But this is basically now, I don't know what's there here. Okay. So now the restrictions of when storing a variable using the type int. You can only use the type int when you're storing any positive and a negative integer. So by integer, that means that the int type cannot take numbers which are not evenly divisible fractions or numbers with the decimal point. For example, if I say int variable equals 5.5, it's going to throw me an error because it'll say something like, let's see what it says. Int cannot be converted to double. This is because a variable of the type int cannot store decimal point numbers, if that makes sense. So we have to say 5. Now, that's the main thing. Let's go ahead and talk about the second data type. Second data type that we're going to cover is double. So double type variable. And the main difference between double and, spelled that wrong, double. The main difference is that you can store, I don't know why it's showing me there. Okay, it's fine now. You can store numbers with a decimal point. That is the main difference between double and integer. So if you want to, I don't know, use calculations that involve, let's say let's say you're dealing with money. There's going to be cents. It's going to be to the cent. You probably want to use a double to store all the information in regards to however you're dealing with the money. Now, the third type of variable that's pretty important is char. So char stands for character. And it can basically store any letter in the alphabet or ASCII value. And ASCII basically means like numbers, exclamation points, question marks, any character symbols. That's what it means. And it can only store one of such thing. So for example, let's say char letter equals A. So the key thing to note here is that we first have to say what type of variable it is. It's a character. Then we give the name of the variable. Then we say what value it can store or what value it's assigned to. Now, notice with a char, you can only store one thing. If I just add a bit more stuff, it's going to throw me an error because it's saying invalid character constant because it can only store one character. And that character must be stored in single quotations. Keep that in mind, must be stored in single quotations, not double, but single. Otherwise, it's going to throw you an error. And it's good practice as well. The fourth type of variable that is very important that you guys should know is Boolean, which is basically true or false. So all you have to say is Boolean status equals true. Basically, a Boolean is kind of like a binary type variable. It can take one value or the other, meaning that the Boolean variable can be true or it can be false. This will be very important when we discuss logic operations, and Boolean variables and factors play a huge role when it comes to determining computer logic. Now, this last type is not a primitive data type. It's actually an object. So an object, I guess you can quite literally interpret it as anything. Let's take a phone, for example. A phone is an object, right? A phone is an object. You can do things with an object that you can't do with the data type. For example, with an object, you can invoke methods on it, which are basically fancy functions. So with the phone, you can play video games on it. So you can call the video game app to open it and run your game. You can also watch YouTube on it by calling the YouTube app, by pushing the button for YouTube and opening it up. You can do all sorts of things on a phone. Whereas just a primitive data type, it only declares, okay, this is the type of variable you're using. You can't invoke actions on it, if that makes sense. You need a class to do that or an object. So this object is a string object. String. And the purpose of having a string object versus a character object is that with the string, you can basically store multiple lines of text. So you can store words, whereas characters, I like to say, can store letters. So you can see a differentiation between the two. So let's go ahead and make a string object. String name equals crucial. So now the main difference between, okay, this is fine. The main difference between string and character is that, as you can see here, this has multiple characters in it, meaning you can store more than one character. And also it's wrapped by double quotes and not just single quotes. That's basically what a string can do. So these are the five main that you should know. Um, a string can invoke methods on it because it is an object and it has methods defining. For example, you can invoke the substring method of it, which will just return a part of the string in the word itself. And we'll go over that a bit later. But these are the main variables, the data types, and I guess a string, if you're going to add it to it, call it a data type, I guess, that you should know. Now, the other thing that we'll be covering in this lesson are mathematical operations. So this is mainly going to concern with int and double. So let's say we want to add two numbers. So let's go ahead and store int num1 equals 5, int num2 equals 6. Let's say we want to add them to a new variable called sum. Int sum equals num1 plus num2. This will return the value, stores the value 11. And why would this store the value 11? Because we're simply adding the values of num1 and num2. Num1 and num1 is 5, num2 is 6. 5 plus 6, 11. It should make simple, intuitive sense. So now that we've covered that part, we can go into something, we can talk a little bit more about variable assignment. So obviously we created all these variables on lines 8 through 20. We have the type, we have the name of the variable you want to call it. And whenever you're naming variables, make sure you try and start with try and name the variable that's something meaningful. So if you were to look at the code later, you'd understand what it means. And then we're assigning it. This is not an equals to sign like in math. This is an assignment operator, meaning the variable called variable name is assigned to the value 5. It's not set equal to the value 5, meaning when it's assigned, it can change. Equals is like a hard, fast rule. Think about it like that. With assignment operators, you can always change the assignment. With an equal to, you're basically saying this is equal to that. And that's kind of like a math way of thinking about it. But we're going to think about it from a perspective of programming. So let's go ahead and go back to line 24. Let's do this. Num1 equals num1 plus num2. So notice something here. Oh, okay. Notice something here. I didn't have to say int num1 is equal to num1 plus 1, 2, because I already told Java what the type of variable it is in line 22. So you don't have to say it again. So what do you guys think this value will be? Well, it'll be 11 again, but it may sound a bit confusing. So let me explain. Num1 has a value of 5. Num2 has a value of 6. So num1 plus num2 is 11, as it is in line 24. But we're going to be storing this 11 back into num1, meaning whatever the value of num1 was before, let's say before it was 5, now the value will be the sum of these two numbers, which is 11. So num1 will equal 11 and not 5. So hopefully that makes sense on how these assignment operators work. Similarly, you can also say num1 plus minus num2 is equal to num1, and this stores the value -1, because 5 minus 6 is -1, and then you're storing that back into num1. Hopefully that makes a little bit more sense. Okay, now let's go ahead and talk about, I guess we're gonna go ahead and talk about addition. Now let's go ahead and talk about multiplication. So let's say you did num1 times num2. So num1 times num2 is 30. And you're going to store that back into num1, meaning you'll get 30 instead of 5. Now, let's say I change the value to, I don't know, 5.5. Or not 5.5. Let's say I did 5, right? Okay. What am I saying? Ignore that part. Let's say I made this, I don't know, 62. And I did num1 divided by num2. So obviously we know that the answer would be 6 point something something, right? So we should expect a 6 point something something. What happens if I run this code, however? If you print out the value of num1, is there an error? Okay, give it a bit. You'll get 10. Now you're thinking to yourself, why is it 10? Why is it not 6 point something something? Well, the reason is because when we do 62 divided by 6, it doesn't divide out evenly. You'll get a decimal point. You'll get 10 point whatever it is. And since we're storing it in a variable that's an integer, meaning that it can only take numbers without a decimal point, what Java will do is that it will cut off everything after the decimal point. So all you're left with is just 10. Otherwise, if it were, not an integer and supposed to say a double, you would get num1 is equal to 6 point something something. So let's go ahead and try that. If we replace this with double, and if we replaced this with double as well, go ahead and replace this with double, and now we run this. Notice we'll get 10.333334. So we do get the decimal when we use double, because double can store decimal values up to 15 places, I believe. Whereas with an integer, all this bit would be just cut off. So hopefully that makes a little bit more sense. So now we'll be going over modulus. So the way modulus works, say I have a number int num3 equals I don't know 15. Okay. What do you think will happen here? Well, how does modulus work? So modulus is actually this percentage sign right here. And basically what you're doing is that when you, let's say you divide 15 by 6, right? So the answer is going to be 2 point something something. So what modulus does is that it returns the remainder. So 6 goes into 15 2 times and you're left over with 3. So the modulus function will return the number 3 for you because that's the remainder of when you divide 15 by 6. So let's go ahead and print it and run it. So as you can see, it returns 3. So modulus is used to return remainders. Okay, now that we've established those rules, we can go ahead and explore Pemdas. So if you guys know what Pemdas is from elementary school, it stands for parentheses, exponents, multiplication, division, addition, subtraction, and everything is left to right. Hopefully that makes sense. So let's go ahead and do this. Do something crazy. 4 times 3. Yeah, it's not 1, 2. See if you can try, go ahead and pause and see if you can try and evaluate this expression on your own. I'm going to run the answer and show you what the compiler says. All right, Nicola, we got 3. So the way it works is that we did 4 times 3 because parentheses, that's 12. 12 mod 7 is 5. Okay. I think, yeah, 5. 5 plus 6 mod 3 and 6, and there's no remainder when you divide that. So it's just 0 because you're doing 6 mod 3, which is 0 times 7. So that's 0. And you're doing minus 2. So all you're doing is 5 minus 2, which should be 3. And that's an example of kind of like all this PEMDAS stuff in just one line. So before we end today's lesson, we're going to talk about, I guess, different ways to increment a variable. So let's say we have int num 5 equals 1. And I want to increment the variable by 1. There are multiple ways of doing this. First, you can say num5 equals num5 plus 1, which makes sense. You're taking this value, adding 1, you're storing it back into the variable. Or you can say num5 plus plus. This does the same thing as line 41. Or you can say num5 plus equals 1, which does this. So these 3 lines of code, they all do the same thing. They increment the variable by 1. If you wanted to increment the variable by 2, you'd have to change this to 2, and you have to change this by 2. So lines 41 and 43 would do the same thing because you're saying num5 is equal to num5 plus 2. The line 42 only increments by 1. Similarly, you can decrement by 1 by doing this. However, let's say you wanted to, I don't know, multiply the variable by 7 or multiply the variable by 2. You just have to do this and you just have to do this. Similarly, if you wanted to divide the variable by 2, you do this and you do this. Or if you want to use the modulo operator, you could just do this and this. Or subtraction is just minus equals, make this a minus sign. That's all you have to do. And this is just a basic lesson on variables and some of the main mathematical operations in Java. And in the next video, we'll be talking about how to, I guess, further manipulate the variables, integer casting, as well as some string methods that we can use along with comparison operators for Boolean. So we've touched upon the five main types of four primitive data types and one object you should know very well. And we've talked about how to modify an integer and a double using mathematical operations. And in the next video, we'll talk about char, Boolean, and string. And then we'll start to go into our first project, which is to build a calculator. Thank you so much for watching the series. I truly hope you've taken away something from this, and please subscribe to the channel. And I can't wait to pub my next video out for you guys to watch and learn. So let me know if you have any feedback, and thanks again.